Here we go.
Thanks, Rudy. Yes, welcome from our side, also from Vienna. And let's take this time to talk a bit about adaptive automation by visual recognition. Uh, on one hand, from the, let's say, perspective of the approach, and on the other hand, with a little bit of hands-on or see for yourself how we at Objentis implemented this approach into our solution Drvless. So uh, first, let's establish some context about this adaptive automation. I think we are at the TestBusters, so I guess most of the talks are about testing, more or less, test software testing. Now, when we say adaptive automation by visual recognition, this gives a slight hint. We are talking more about user interfaces. Now, user interfaces, when we automate user interfaces or test user interfaces, so automating the user interface does not necessarily mean testing the user interface. Sometimes you just need the user interface to test something via the user interface. And I think this is an important differentiation in our terms, especially when we talk now about this adaptive part. So when you test the user interface itself, you check most probably for layout correctness, for stylings, color, spacing, also for visual regressions. So this whole topic around visual regression testing is partially about testing the user interface. But another aspect of automating the user interface is testing via the UI in order to, let's say, test your business workflow execution, to test if the outcomes that the user runs through the user interface are actually correct from an end-to-end perspective, or generally speaking, is the system behavior correct through the user interface? Yeah. Now, UI automation somehow gained something like I would say, a bad reputation. At least that's my experience across the last 20 years or something. You try to avoid them, right? You also have this nice testing parameter that tells you, okay, do a lot at the very low level, at the unit test level, component level, and then it gets smaller and smaller. And in the end, you would like to have just a few tests really across this full line. And there are several reasons for this, right? One reason for this is, okay, of course, it's nice to test the things isolated, but many issues with UI automation is, on one hand, it's slow, typically slower than, let's see, acting directly on the code. They are quite often brittle, break. It's hard to tell why. So it's also quite often hard to diagnose or analyze why a specific UI test is failing, because there's so many reasons why a UI test can fail. And as a result, they're quite often expensive to maintain, right? Or you have to put a lot of effort in it. Now, in some cases, even when you don't want to test the UI itself, it might still make sense to test via the UI. For example, you want to test third-party applications or black box systems where you don't have any technical access into it. Or you really want to have a final validation across some process from the user perspective. So when we say adaptive automation to make UI automation easier, more stable, the goal is not that, okay, let's toss out all the lower level tests, but to make those tests that make sense on the UI level, to make them more resilient, to have there really a way to work on. Now, from these four bullets that we have here, the three on the right side, many of those issues are related to one effect that is, in my opinion, with UI tests more often the case than with, let's say, API tests, for example, which is the topic of false failures, meaning my automated test fails, but it's not really an issue, right? It's not really an issue for the user. In the end, we want to check whether the whether the user is affected. So how comes that this is more often the case for UI tests? Well, mostly the UI automation follows the implementation of, let's say, your front end. And the automation is coupled more or less tightly to, let's say, the DOM tree of your web page, or some specific control structure hierarchy types of controls that are somewhere in the system, and your automation connects directly to them or uses some locators to find the right elements in order to interact with them. Now, if there is some changes on some level in this UI layer, tests quite often fail. But this doesn't mean necessarily that the user cannot work with the application any longer. It only means your test is not running any longer, right? And this leads to the fact that you have a lot of failures. You have a lot of work with refactoring them, and you have quite often dashboards that are usually read with UI tests, and it's hard to tell whether a problem is a real problem. So one approach to handle this, and this is, I think, gaining a lot of traction across the last years, actually, is the topic of self-healing tests, right? I'm not an expert in self-healing tests. From my understanding, the general approach is, okay, you have some UI change. The test, the self-healing framework detects, okay, this locator is not working any longer, and it finds some alternative to find the desired element or the other class type, etc. And then it will apply a patch to the test and run it again, right, to find whether it's still working. So this is very nice because you have way less manual work on making your tests running. So you have a faster recovery, you have less disturbance. But what's still true is your test fails first, even if this failure is hidden somewhere. And while the self-healing takes another way, you still have the same technological dependency on the system or on the framework that is being automated. And of course, also the self-healing can sometimes fail, but I guess that's the case for everything where you have some dynamic. Another point is, so when you see I'm using something self-healing, so it's hard to define where the boundaries, right? So what is allowed for the test to heal, and what must stay stable. So with this increasing usage of large language models in many fields, when is the point reached where your test is doing something that you did not intend for it to do? Now, with this, let's say, with this focus on the problem that we have when we access the application under test on this technical level, of course, this is a different approach, and this is also not something that is new, right? So you can, let's say, handle your user interface just as an image. And there were ways already that you take this image and do some image matching, template matching, to find whether this is the correct form, in order to find the proper fields, etc. And this is a feasible approach for some cases, but not all of them, right? So for different kinds of UI changes, you will see, okay, for some of them, the selector-based automation or the currently traditional UI automation works fine or breaks, right? Depending on what kind of locators you're using, where the image matching would work, and vice versa, right? So it's kind of, okay, you can decide which one you use, but you will, in both ways, you will find something that is not really working. So this is not a question about, okay, do we do selector-based or visual-based? The thing about adaptive automation via visual recognition or by visual recognition is to, let's say, leave out the selectors at all, but also don't look at specific pixels or specific reference images for your automation, but do something else, right? So, kind of a different concept. For example, here we have now this two versions of basically the same application. We have basically the same input fields, the same buttons, the same functionality, but they look more or less totally different. Could be, I mean, I know it now because both are now browser applications, but this could also be some native application, some terminal application, etc. So when we say visual recognition, the process is, okay, we feed this image of the application into some lightweight machine learning model. And this machine learning model is trained with hundreds, thousands of screens from different user interfaces, so that this model kind of knows what would be a field, what would be a button, what would be a menu, what would be an icon. And it will create an internal representation of what was detected. It also runs some text recognition to find out which are the labels, so what's the meaning of the different elements, and it can address then those elements in the end on the runtime based on where a specific element was found, how it was classified, and with this adaptive approach, you can use the same description, for example, in this case, to fill either the form on the left side or on the right side, because while from locator perspective or from a template perspective, they are different. For a human, when the human gets the instruction, okay, fill out this form with this data and calculate some amount, a human most likely will also be able to do this. So this is the base, let's say the base input. And how this works, we will see in a few minutes in a live demo. But first, let's go a bit into what's the impact of this, and also what are typical or best fit use cases for such an approach. So with this shift from the let's say technical connection from my test case or my test framework to the system under test, towards a purely visual approach, some things change, some things stay the same. Right. Okay. So what's still the same from a UI automation perspective? It's still slower than, let's say, lower level checks. Right? It's so from our solution, we are using these lightweight machine learning models, which are way less hardware intense than let's say a large language model, and way faster. But it's still, let's say, it needs some processing power. What really changes from this approach is that the debugging, the analysis for anything that is failing, that is not running according to my expectation, is directly traceable to what's visually displayed on the screen, right? Because I can exactly see, okay, what was displayed, what was recognized, and where was clicked, what was waited for, etc. On the other hand, other boundaries means from this purely visual perspective, when we say, okay, we just feed the visual image of the application under test into the system, and we don't have any technical access to it, means also we don't have access to any hidden text. We cannot, let's say, read a text that is white text on white background, or we cannot, let's say, find all the drop-down values without clicking on the drop-down first to look it up. Now, this is just something you need to be aware of, right? Because you can you can also see it as an upside because it's more or closer to the thing that the human actually feels, experiences when the user is working with the application. So with this changes, okay, what would be the best use cases, or where this fits best, right? I would say there are three areas which have some overlaps, but each of them stands on their own, right? On one hand, you have in some cases you have software to test where you have very limited technical access, be it that it is some third-party software where you don't have access to the developers, to the source code, to anything, be it that it is some legacy systems that are still in your organization in place, with old or not so old but outdated, or not outdated, let's say stabilized base frameworks. Or you could also have something more like a black box environment, mobile applications, point of sale systems, basically anything where you have really a different, say, experience than with the standard application development systems. So this would be one area where this is really, let's say, the door opener to finally be able to automate something. On the other hand, when you have your focus on business critical workflows from an end-to-end perspective, workflows going across several systems, across several technologies, this has a big advantage because you can treat them all the same, more or less, right? So you can run through a web shop system and then validate the back office, which could be some SAP or whatever. Yeah? Or when you want to have some final validation test processes, acceptance tests, automated acceptance regression tests that you want to run via the user interface. And of course, also everywhere where you don't have stable selectors, where it's quite dynamic, be it because your framework just generates always fresh stuff, where your UI is in frequent evolution, or also when you have some customizing projects, like you have customizing for Salesforce, for SAP, with some standard parts and additional parts added by different teams, added during a project. Right. Now, before we go to the live demo, what this approach actually, the impact that's, let's say, on the tester who's working on this automation, what changes there, right? In the traditional UI automation, you have a lot of effort, typically with keeping your locators, object repository up to date. Debugging is quite often a very, let's see, it's a tricky thing, and it's also often a lonesome thing, right? Because in my experience, so it's just, well, yeah, that's a problem of the test automation, right? You find something, it's hard to explain to the business owner what the real issue is when it doesn't reflect on the user interface. And quite often it's also hard to explain to the developer that I have a problem with keeping this automation up to date because, well, he says, well, my unit tests are working, just make it work, right? And the failure rate or false failure rate is a real trust issue from my experience. So with the shift with the adaptive visual automation goes more into a bit less technical work, but failing tests have a much more reflection of visible issues on the user interface. So you can easily go to your product owner and say, okay, well, look, it now looks that way. That's why my test is failing. Is this what you think that your users want to have? Right? And so this follows up to the next term, right? The analysis is closer to the user experience. And the overall goal of this adaptive automation, like in all tests, is we don't, so the goal is not that the green pipeline all the time. The goal is to have some alerts where it really matters. And yeah, this might also be some separation, because you would still have reproducible tests, or you will still have reproducible tests, traceable results, opposed to, let's say, some more free-forming adaptive process that just decides on its own where to go. This adaptive automation by visual recognition just refers to the dynamic in the location of the elements. And to see this now, how, let's put it, a possible implementation or one existing implementation of this approach, I will hand over to Johann Sebastian for a very short live demo.
Yeah,
Thank
thanks. Thank you, Theodor. You already told them a lot of what I wanted to tell them, but that's okay, of course. I will show you instead what this driverless implementation looks like hands-on, and how we can implement adaptive test cases in driverless. So let me share my screen first. Things first. Here we go. So, oh, there we go. All right. First of all, this is the test case editor of driverless. It's a bit much, don't worry about it. I won't go into technicalities today. If you're interested in them, you can contact us. But for now, we will just focus on these singular blocks here. And before I explain what each of them do, which I hopefully don't have to do too much, I would like to show you what driverless sees. Theo already showed you a sneak peek of that, and how driverless sees the world. So I have a virtual machine connected to my server here. It looks like this. I've here open a demo car insurance program that we set up. We have a lot of fields here which we can fill out, and then we can calculate a premium, and this value is given, and that this value we want to test, basically. Now, this may, for example, be our backend or an early version of our insurance model, and maybe, for instance, the story is that our marketing comes along and says, well, that's not beautiful, we can't ship this to our customers, make it more easy to see, because it's, it has squares in the back and it's blue and has the courier font and everything. So we've developed a test for this, and we want to reuse the same test for our new page. This new page is different. There's a different layout. The fields are in a different order. And yeah, it is visually very different from our backend, I should call it. And what I will show you now is that these two systems will be able to be tested by the same test case, which I've got here. Now, how does driverless, this is the world that driverless sees. How does see driverless the world? I will run an annotation here. And it draws these rectangles around every item that it recognizes. We are specifically interested for today in these boxes here. You see that the text is marked by purple boxes, and everything else is marked by green boxes. These green boxes may be input boxes, but they may also be buttons, for example, or maybe I can find an icon. Yeah, there would be an icon right here. Different types of items. So if I tell driverless to write into name, which means the box labeled by name, the text Theodor Hartmann, then it will do just that. And I will run this entire test case. Well, actually, let's run only this singular block, and we can look at what Drvless does in this live view. Well, this one block happened way too fast right now. But I can see that it clicked here. This yellow circle with the red cross indicates a mouse click, and it sent the text. And if I show you the virtual machine right now, you can see how this box is filled. I will empty it again to reset my starting conditions. And I will execute this entire test case now, which just fills out the form. It selects from a drop-down an entry, and then it hits the calculate premium button, and we should see the number 340 on screen, meaning we have a price of 340 euros calculated. Let me quickly check that I'm connected correctly. Yes. Now I'm performing this live, and each time Drvless does an annotation, we can see the screen shift. And what we can see here, the verification has succeeded. It shows us that we indeed have the number 340 on screen. And yeah, success. Now I will switch over to our new interface. This is the new interface. And I'll start the exact same test case again. I'm not doing anything between these runs, just start it again. As you can see, in a minute, once Drvless decides it's time for a new annotation. Yeah, there we go. We can see how that it truly does not rely on any indicators or anything. It really just uses the screenshot from our system under test. It evaluates which items it can see, and then it does something to these items according to my test case. All right. So if I say write into name Theodor Hartmann, and there are multiple fields with the same name on screen, let's show you how this could look like. For example, I have different billing address than my living address. In both, I need to set a city, and both of these boxes will be labeled by city. I will show this to you right now. So we have here the text city, and then underneath the box called city, and also under living address. So this is a problem, right? Because if I want to write text into the living address, then Drvless's standard configuration chooses the first one it sees from the top left, I think, and will always go into the billing address box. So what we invented is a little navigation. So we need to set a so-called anchor point. I'll just grab this text from here. Now I want to go, live coding. This is always a good idea. Now I want to go to the element, which is a box labeled by city, which is to the bottom right of this original anchor. I can enter city here. This will be a box. And I want to write into this box my whatever I want to write. And now, for good measure, I'm checking if this text really is on screen. And I'll execute this this is already a little test case here. I will execute this. And if we are looking now what Drvless is really doing, it focuses on this text living address. It looks it looks below right to this label for a box called city, which it found right here. And then it just enters its text here and does a verification just as we told it to. All right. Now, one extra step up from this is tables. It's a bit much right now. Basically, this is the important part. In this little segment here, I've hidden all of the formula filling. You've seen this already, so I can hide it. And once we doing a calculation, we are telling Drvless to recognize a table because we know there is one. And then within this table, I'm doing a table navigation and verifying that we are getting correct prices here. So I'm doing multiple verifications for this. So this is just the same segment copied over and adjusted. And if I'll show you, of course, again, first how what we are looking at, such that you know what's going on. And now if we let Drvless handle this, very good. I can see it already on my second monitor that everything is working. The table has been created, has been filled, and all of the entries that we wanted to check for are truly here. So this is the first one. Sorry, here it verifies the first row, and then if I go on, set anchor point and verify, verifies the second, and so on. All right. I think that we are at the end of our time. We wanted to leave some room for questions. I already saw some in the chat popping up, which I wanted to answer, but let's keep it orderly and go by it one by one.
Now let's start. First question. If I build my first automated test, how do I teach the model what a button is?
So when you use Drvless, you get this model, and this model is with already, this knows already a lot of buttons. If you have some very new thingy of buttons that are not used anywhere else, then you might have to add 50, 100 screens with this button being annotated to the model training. And if you're using our solution, you can provide this to us, and then it will know this button.
Okay.
Or not this button, but any button that is like this button.
Okay. Next question.
All right.
Sorry, please, Theo.
So it's totally different thinking.
So wait.
You want to read the question?
Yes.
Please read the question.
So, is this like Selenium, but just without locators, or totally different thinking?
It's totally different thinking in terms of how the system is being accessed. It's partially similar because it's still a test procedure that you define. So you still say, okay, these are my steps that I want to execute during my tests. These are my assertions that I want to make. So this is not going wild and doing anything. But the way it accesses the system is not like Selenium, it's not like Appium, it's not like Ranorex, it's not like Tosca or whatever other framework you would use.
Okay. How do you balance false positives versus false negatives in your visual detection models?
Well, that's a good question. And to be honest, I think I would need someone else from my team to answer this properly. If Anonymous reaches out to us afterwards, I'm happy to provide a useful answer.
A good idea. Yes, a good idea. Okay, so that means, okay. Next one. How do you handle dynamic components like drop-downs or lazy loaded elements?
I think I can answer that. You are usually doing what you would do as a human, right? So if the drop-down requires you to click into it, then you say click into the drop-down and then search for your entry. We in the Drvless application, we have drop-downs that appear while you hover over them. This can also be done. So you hover and then choose your pick.
Okay. Yeah. And I also do a double click. Do you combine visual recognition with DOM signals or fully decoupled from it?
We have it fully decoupled. We actually don't, so we even have a mode where you run it, let's say, physically decoupled or physically coupled just via an HDMI cable and a USB cable for sending keyboard mouse requests. So there is no other access to the memory of the system under test.
Okay. Next one. What happens if the UI element is partly hidden or overlapped?
Depends. Depends how much.
Oh, I like answers like that. Okay, so that will be a rule for the next one. Answers with it depends are not allowed. Thank you so much, Kate.
Great, happy to provide new rules.
Okay, sorry. What was
so honestly, it really depends on how much is hidden or overlapped. But in general, so what is if there is an overlap and let's say you can see just half of the field's content, or the model will only know half of this field's content, for example. It quite often still detects buttons or input fields still as such elements, except when it's really not much enough to see. And one thing about active, inactive windows, because overlapping is often a dialog, right? That pops up and then overlaps some stuff. So this is something, that will come very soon into our system and to handle this.
Okay.
With more support.
How much setup I need before I can start using visual recognition?
Yeah. So go for Drvless. You just need to plug in the HDMI cable and the USB cable, so there is really no big setup needed. Of course, so if we talk about our solution, of course there are different deployment models. You can run it on premises on your own hardware. Then you have a bit of setup to run, let's say, to establish the server that runs the model recognition, or you can use a SaaS solution that then really just runs either a program on your device or uses a hardware adapter to connect to the system, and you can get started.
Next one. How do you handle localization, like same button but different language text?
Okay, there are two to three approaches, right? So on one hand, you can provide some label map, some localized label map, which use a lookup for, so use the same key, and then depending on the language of your user interface, use a different actual key that you want to look for. On the other hand, for this part specifically, we also allowed something like a self-healing stuff, where we integrate, where you can integrate a large language model or a small language model for exactly this task, so that when an element is searched for and it's not available on the screen, that then just in this case the model jumps in and says, okay, well, you might want to click on this button, or you might want to click on that. And for localization, this works quite well.
Next one. How do testers validate that the model actually sees the correct element?
So if we talk about testers, like people who are using this system and use this for testing, that's how I understand it now. So the testers validate that the model actually sees the correct element. Well, you would probably at least once run this test, let's say in an attended mode, right? And watch while it's running, or watch afterwards in the results whether it really took the right ones. The advantage of this approach is that let's say that the same screen gives you the same recognition all the time.
Is it possible? Is possible of have a functionality if a selector-based test fails? It would be cool if a gherkin step fails. It tries to heal itself trying to evil step text. Okay.
I think I cannot answer this. I'm not sure if I understand the question correct. So, but okay, I will try to answer it. So
yes,
is it possible? So if let's say what Johann Sebastian showed us, there was this write into field date of birth, some date. Now could be that this field is not available any longer, right? So what you can define in your tests also, especially for stuff where you might expect that it's there in some cases, maybe it's just on the 29th of February, there is some specific case and you're already aware of this. There is also a concept of a try catch, where you can, let's say, make a fallback to something else, and then do something different. And you can also repeat stuff, and so you can do loops and try to, let's say, try to find some variants for a specific flow on a prepared base.
Okay. Any restrictions on platforms, desktop, iPhone, operating systems?
So from the mentioned desktop, iPhone, no, none. So the main requirement is that the system has a user interface, and that this user interface is somehow receivable best via HDMI. In general, it would, or not, it would. We also did a proof of concept with taking the image from a camera that is, let's say, pointed at the device, and then really using a robot arm to, let's say, touch the display or press some keyboard buttons. There is a slightly different, let's say, translation layer then from the coordinates to what action is needed, but it's really independent of this. And so yeah, I think that's probably. And yes, we can. Sorry, question.
Wait. Yeah, and it was not green. Okay.
It was okay.
It is green. So can you run it on mirrored system, e.g. remote desktop, VNC, TeamViewer, or do you need direct access to the system?
No, so you can run it on mirrored systems. So you can, if it's a application that is there via Citrix or VNC or TeamViewer or remote desktop connection, it really doesn't need, let's say, anything behind it. Yeah.